VLPSos here. This is a video lesson for Python programming, ordinals. I recommend pausing on occasion to practice. Every symbol and character on all computers has an ordinal number. Each symbol has the same ordinal number in most comprehensive languages. This means the ordered list of all symbols has been standardized. The list called ASCII, A-S-C-I-I, which stands for American Standard Code for Information Interchanged, used to be very short. Now the list has many thousands of recognized characters with room for more to be registered. We can find the ordinal number of each character on this list with the ord function. For example, if we call the ord function and put in a character or a single length string, it will return the ordinal number of that character, its position on the ASCII list. And if we want to see it, what that ordinal number is, we'll put it into a print. Saving and running shows us the ordinal number of the character lowercase a. And we can see that there are different ordinal numbers for different characters by printing out a couple more. In this case, we'll print the ordinal number of ampersand, and even the special character /n, which stands for new line, will have an ordinal number. And we see their ordinal numbers are 97, 38, and 10 for the new line character. We make a note the last was a special character, not a symbol, because the list was created for telecommunications in the early 1960s. The first 32 ordinals on the list are control characters, things like shift, tab, escape, which are not symbols, but still very important and common keyboard keys. We can observe the character associated with each integer with the character function. In other words, the ord function, if we give it a character, will give us the integer number of that character on the list. And we can reverse that process by putting an integer into the character function to see what character that's the ordinal number for. The character function is abbreviated CHR, and if we put 97 into the character function, it will give us the symbol that is associated with that ordinal number. And if we want to see it when we run, we put that into a print statement. We can see that the character with an ordinal value of 97 is A, because the first line of our code gave us the ordinal number of the character A. So we have reversed the process with the character function. And we can do this again with 38, which is the ordinal number of, we expect, ampersand, and But in this case, I'm going to put more into the print statement, not just finding the character whose ordinal value is 10, but we'll supply it with a pipe and then another pipe to more easily observe the output. Saving and running reverses the process so that we can see the character A and ampersand, and the pipes were split because when making a character out of ordinal number 10, it gave us a new line, and we can see the evidence that a new line must have happened because we have a split in those pipe symbols. The last example included some other characters to observe the effects of ASCII character number 10, which is the new line effect, originally called line feed, the line feed control character. Line feed is the old name for that particular character on the list. Let's view the original list, the original ASCII list in its entirety. In order to see it, we're going to use a for loop to print two columns. The first column in the printout will be the number, the ordinal number, and the second will be the character with that ordinal number. To produce this list, we'll have a for loop of count in range from 0 to 128. There were 128 original symbols in the list. And every time we iterate, we will print the integer or ordinal number and the string, which will be the character. The integer will be count, the ordinal number, and we'll get the character with the character function, chr, putting count, that ordinal number, in. Running this gives us 128 prints. Observing this list, we can see that the first 32 characters with those ordinal numbers 0 through 32 or 0 through 31 were spaces or rectangles. Because these are mostly control characters that don't have a symbolic representation, there are the keys escape and the various shifts and other keys on the keyboard. We can see that something was printed in its place. It's only when we get to ordinal number 33 that we start to see familiar characters. The first ordinals in the character list 33 through 46 were punctuations. Those are the shift versions of the numbers on a common keyboard. We can see that the integers are represented, then more punctuation in common keyboard symbols. Then the capital alphabet is ordinal number 65 through 90. Parentheses, the lowercase alphabet starts at 97 up to 122, and then we finish with some more parentheses until the last ordinal on the original list was 127, which now corresponds, I believe, to the delete key. The next 128 characters, beyond the first 128, is commonly called the extended set. And we can print those just as we did before if we change the range from 0 and start at 129 and go to 256. So we can see both the original set and then the extension. In the extension, we can see that it starts at 129. We see space in the list, more punctuation that is less common to be used, but things like pound symbol, copyright symbol, paragraph, plus minus for mathematics, a couple of common fractions, and then the alphabet with expressive or alternate letters that can be often found in foreign languages, some Greek letters, accented letters, you can see for yourself. In the full modern set, which exists today, there is some very interesting stuff. The full set has many thousands of characters and a whole lot of room in it for other characters to be registered. Just to see a few, we'll print the character with the ordinal number 2529. And another one that might be interesting, 1769. 2039. 1904. And 1134. Those characters with those high ordinal numbers, we can see look very interesting. In the complete set, there are a lot of symbols. And to finish up, now you. You have seen how ord and character functions can access the standardized list of the characters that a computer can display. Explore and find a few characters that you think are neat. Write a simple program that displays them and their ordinal number.